Good afternoon. So today we're going to continue studying maps, multimaps, and pairs. And then, I'm going to give you a heads up, we are going to switch to a topic that I don't usually cover in 10B called templates. And I will be posting new lecture slides on CCLE and I guess under week 9. But these are not, you don't have these. These were not contained in week 1 in that zip file of all lecture notes. But I will cover templates, which is not something I usually do in 10B, but I've decided to do it instead of the binary arithmetic section. Okay? So just a heads up, we're going to finish today with maps and multimaps, and then we'll move on to templates for the next topic. And then your final homework assignment will be to, I'll give you a heads up on this, you have your homework assignment due on Friday, which is to implement a linked list, and then you're going to template the linked list, whatever that means, for your final homework assignment, and then you will have a list container very much like the standard libraries list. It'll look and feel very much like that container. Okay, so that's the direction we're heading. So recall from the end of last time, we went over this idea that a map is a way to connect pairs of values. You traditionally think of a function or a map like a formula, a recipe, x squared. But what you're really saying is, you give me an x, and for each x you give me, I have its matching value. Okay? So if we have a formula, we can we can compute the matching pairs for a whole range of values. But if you have a function that takes, for example, a string to a double, or say a string to an int, which is a student's name to an ID number, that's not just usually a formula, that's just, well, for this particular individual, we've arbitrarily picked this number, and we're just going to list all of those pairs. Rather than coming up with a formula or a recipe for all such possible names, we just specify a fixed number of them and their matching values. So that's what a map is. A map is just, in a sense, it's just a way to associate pairs of values together. Okay? So, okay, we went that last time. Okay, so basically the idea is the following, is there's no real good formula here. If we're thinking about maybe the course number that these individuals are taking, you know, there's no formula which tells you Bob's number is 5112. The formula, it's not a numerical formula in that sense. It's a formula in the sense of, oh, Bob is signed up for this class. It has this number. I want to associate the pair Bob and 5112. Okay? And the thing about a map is that you can have multiple elements on the left get mapped to the same value on the right. Okay? So that's, you know, very, I guess, nicely worded as a many-to-one mapping. Okay? So many different objects here can map to the same element there. That's no problem. That's just like a function like x squared. Both 2 and negative 2 map to the value 4. There's nothing inherently bad about that. Okay? So we're just saying for these particular set of values, we're going to just specifically mention which their mapped values are. Okay? So there's a container for that. There is a data type for that. It's called map. So we number include map, and then we can add in elements as we please. And the way we add in elements is kind of like using the vector notation, which is why maps are, this is the beauty of C++, and I'm sure a lot of other languages have this as well, is that if I were to replace map with, say, like a vector, it would look very similar. The notation, the syntax would look very similar. Okay? So, excuse me. Here, for a vector, you need a non-negative, you know, an unsigned int index. But for a map, the index can be anything, like Bob or a string. Or you could even do an index based on a point2D object. Okay? So it doesn't matter. You just do map of whatever object you want to be what's called the key, and then whatever object you want to be what's called the value, and they're called the key-value pair. Right? And that's how you would assign values accordingly. Doing like ID of Hamlet equals 7123, and then, for example, you know, for Spock, if you want to print out the value, you do ID of Spock. What it actually does is it actually searches for Spock finds the value that Spock maps to, and returns that value. Okay. So it's similar to a vector in notational style, but internally it's doing a lot of different other things. Okay? But as far as you're concerned, the programmer using this library, it should be very natural and correspond to what you would think of like a vector. Okay? So let's see. In a function like f of x equals x squared, all values of x have a specified rule to determine the output. But for our map ID, we only have specified a few cases. So for example, let's suppose we wanted to see if Luke was in our list, but there's no guarantee that Luke actually has a mapped value. Okay? So just because we have this idea of a map which maps certain string values to certain int values, it doesn't mean that all possible strings have a relationship with an int value. Okay? So unlike with a vector where you do like v of 0, 1, 2, 3, etc., if you were to do ID of Luke, there may not be any value in the container that it maps to. And so you probably want to have an operation like find. Because there you say, all right, well, I have a set of relationships between strings and ints, but I want to know if Luke is part of that set of defined relationships. But here's a good question, which is if we try to search for Luke, what should id.find return? Sorry, a binary. What do you mean by binary? Oh, a Boolean, right? Yeah, okay. A binary valued data type like bool. Yes. So a bool, like true or false. That's one way to do it. You might want to know, is Luke in the list or is Luke not in the list? What's another way you might want to do it? If Luke is in the list, though, what probably might you want to know? Well, its value, right? You probably want to know the value Luke maps to, right? Or you may want to know who's on either side of Luke, who's next to Luke in this list, or something. So instead of just returning true or false, you could return what? How about an iterator? Okay? Now, if you find, for example, Luke in the list, you return an iterator to that node, to that internal location. Then you can print out its value, okay, because you know exactly you're pointing to that node. Or if it's not in the list, you have it go to a state which is one after the last element in the container. Okay? Why would you do that? You would do that because don't forget reading this for a second. Okay, so you have this collection of pairs of elements, of basically these pairs connecting this key to this value. If Luke or Spock are in that list, you want to be able to point to that element so you can access both the name Spock and the value it maps to. Okay? So returning true or false is one way to answer the question, but if the answer is false, that's great. There's nothing morally more we'd want to do. But if the answer is true, then we'd want to do more. So rather than just returning a Boolean, if we return an iterator, we can then do more. And then if it's not in the list, we can have that iterator be returned in a state which indicates it wasn't found in the list. Okay? So here's the better question now, which is, suppose you return an iterator to an element in a map. What does a map consist of? Okay. So the answer is, it actually points to what's called a pair data type. A pair is quite literally a class with two public members called, guess what? First and second. Okay? So it is a class object that literally just consists of first and second public member variables. So a map is just a collection of these objects of type pair. Okay? So the pair data type is what's called templated, just like a vector, just like map, and it has two different data types, like a string and then an int. In other words, the first data type would be a string, the second data type would be an int, or we denote that by k and v. Okay, simple enough. For example, here you can make a pair of objects called for int and double. Maybe it's an ID number, and maybe the double is the GPA of the student. Okay? Basically just defining a set of pairs. The first data type is called the key, and the second data type is called the value. So here when you have like Bob, and then you have 1152, Bob is the key. That's the key by which you're going to search for that particular pair of elements. And then the value corresponding to Bob is the 1152. Okay? So let's just take a look at this code one part at a time. Okay? So look at the top part. So we can create a pair called student. It's of type pair of string to int. And it is a student that is going to have a name and, say, an ID number. Now, how you make a, so we'll get to that in a second. How do you make a pair object? You can actually make a pair object by calling a function called, make underscore pair. You just input two values, and it returns an object of type pair using those whatever data types those elements are. So here by calling make pair, I'm creating a pair object with those values and assigning it to student. I could also do it all at once. Actually, let me rewrite the code in C++ so that I can play around with it. Okay, here we go. Let's save all this, but not use it. Okay, so here we go. Put that there. We're going to include map, and then number include utility. Wait, if I don't include utility, it should give me an error. This is going to give me an error because it's the wrong character. And I also need a map of string to ints called ID. There we go. All right, now let's see. Oh, and I have a typo. Make sure that. Okay. Okay. Let's print that out and see what happens. New student Luke, ID 12345. Okay. So a simpler way to do this is the following. So I'm just going to, rather than calling a make pair, there's a constructor which allows you to construct a pair object just by inputting two values like so. And I've gotten rid of using that function. Okay. You'll note that the object student has two public member variables. So I can call student.first, student.second. I can overwrite those values as much as I want. So a pair gives you two public members. Another thing I could do is insert student. Another thing I can do is id.insert. And I can do make pair. I can do, say, Leia 54321. And I can insert a pair object directly. And then I can cout ID of Leia. Like so. Okay? So that's that. Go back to the slides. Okay? So again, two public data members. And then there are many different ways we can insert a pair object into a map. Again, either create a pair yourself of type, type pair, call make pair, or create a student object and then later on overwrite the values and call insert again. So that's another thing you can do. There's a question, I'll get right to it in a second. Now that I've created a student object and I've already inserted it, I can do student.first equals, say, Anakin. Student.second equals 98765. And I can call id.insert on student. And what it does is it just copies the values into some internal node, which is a pair of type pair, well, which contains an object of type pair. Okay. Yeah, there's that. And then if I wanted to print out all of these, I think this will work. Let's see. It's been a while. For auto x in id, cout x. Actually, that probably won't work because x is not of type. If I did x dot first colon x dot second, there we go. Now this should work. And there we go, like that. Okay, so there I was able to print out all. Well, let me put in a return carriage there to make it easier to see. Okay. So here we'll put in a Endel. Okay, so, and there you go. Anakin, Leia, Luke. And what order did it print them out in? Alphabetical based on the string type. So you'll notice Anakin came first, even though he was the last to be inserted. Then Leia came next, and then finally Luke. That's purely because it's alphabetical order in the string variable type, in the key value type. Okay, so the key thing to keep in mind is that maps accept pairs as their sort of internal objects. So you can either create a pair object and call insert on it. You can call id.insert on the makePair function, which returns an object of type pair. Okay. You can also take that pair object, student, and you can overwrite the values and then call insert on it again. And all insert's doing is it's taking those values and copying the values to some internal data structure. That's why you can reuse the student object over and over. Then the cool part is, again, this is a new C++ 11 thing. Range-based for loop. You have a collection of pairs of objects. They're stored internally in the map somehow. I haven't told you how they're stored yet. You just know they're stored there. Now, for each element, x, in the collection ID, each element is a pair data type, right? So calling x.first and x.second gives you the key and then the value. And because they're public member variables, you can access them directly. Make sense? Okay, was there a question? I backtracked. I don't remember. I don't know if I get internet in this room either. Yeah, I don't get internet in this room. Let's see. I may have utility already included up here. I don't. Yeah. They also did some things in C++ 11 where, or map maybe already includes what you need for the pair. So, yeah, don't hold me to that. You need number include utility, and I won't hold you to that either because I didn't mention it, or I didn't have it in the slides. So, I'm not 100%. I think pair is part of the utility library, but I think by just including map, I think you might get it included automatically. I'm not 100% on that. But all you need to know is you must include map to access the map. And then as apparently as it seems here, it seems like unless utility is hidden in one of these other ones. Okay, here's a good way to check. Let's get rid of everything else that we don't need. Okay, looks like you just need map. So, yeah. Okay, so now we do the search for Spock. And here's the pre-C++ 11 way to write the code. How many of you like looking at this code? Is it enjoyable to anybody to look at all of these like letters and colons everywhere? It's not to me. I love programming. Don't get me wrong. I don't like looking at this. Okay? Let's C++ 11ify this code. All right? Now, I'm going to teach you you remember this auto keyword I keep only using for range-based for loops? You are allowed to use it, but only in one situation, when it takes the place of an iterator type. Okay? The auto keyword may only be used in Pick 10b this quarter if it is taking the place of an iterator type. Nowhere else. I don't care if your code would compile and run beautifully using the auto keyword on a handwritten solution, for example, on an exam. You can only use auto if it is taking the place of an iterator type. Otherwise, you get points marked off for style. Just want to make that clear. Okay. So let's C++ 11 autoify this code right here. Okay? So let's take this. Now, there is no Spock in my map ID at the moment. Okay? So first of all, let's clean this up a little bit. So let's take, we inserted student, we inserted make pair. Let's get rid of these output statements. We've inserted Leia, it seems, twice now. So let's get rid of that one. We can keep the student first and second as Anakin and insert him. We can keep the printing them all out. Now let's do the search for Spock. So here, like I said, we want to do an id.find on the string the search for, which is assigned to be Spock. That's fine. But then instead of, so now instead of writing map of string to int : iterator, just write auto. Okay? Now, I realize all I did was change one little piece. But let's read this now a little bit easier. We're going to search for the string called Spock. We're going to return some data type, some iterator type. And if it does not equal to end, then we found it. Okay? So if it does not equal id.end, then that means that we have an iterator pointing to a valid element. If, however, POS is equivalent to what id.end returns, then it wasn't in the list, and we've been returned this default value so that we can indicate that it's not in the list. Okay? So if POS is equal to id.end, then that means Spock was not found in this map, and we're going to output that. Otherwise, we're going to return the ID of Spock is, and we're going to return its ID. Okay? So this auto keyword will come in even more handy in a little bit, and I'll show you why. But let's just do this first. So we were unable to locate Spock. Very unfortunate, but true. Now let's let's do the good old-fashioned way. So forget about pairs for a second. id.spock, or id of Spock, is equal to, say, 3141. Okay? Now if we run this again, the ID of Spock is 3141. And Spock goes at the end of the printout, not because it was the last one inserted, but because S, capital S, is greater than all of the other preceding strings. All right. Let us continue. Print. Printing exactly the same as before, only now we probably want to print using the key and the value instead of just the value. I jumped the gun a little bit on this slide. I've already shown you how to print. Do you even need to do any of this? No. You have what? Auto, but in particular you have, which is, yeah, I'm just looking for a very particular word, or words. It's called the, yeah, the range-based for loop. Yeah, exactly. Okay. So, all right. So, that auto x in whatever, that's called it has a name. It's called the range-based for loop. There we go. Range-based for loop to print out all elements. Okay. Now we can take this. Let's actually take this code and let's not auto-rangeify it. Let's just C++. Let's just autoify it. Okay. So let's take this code and let's see how to at least just autoify it. Okay. So we have this. We're just going to print everything out twice. That's fine. So rather than, I have this quotation is the funky one. Whenever you copy and paste quotations, sometimes they come out a little weird. So this works. So let's just run this to. Oh, that's weird. Oh, I've redefined POS twice. Okay. Let's call this POS save. Let's just call this one POS2. Okay. It's just a name conflict, that's all. Okay. So we print that. We get them printed out twice. And then the ID of Spock is 3141. Okay. How do we C++ 11ify this? Well, okay. Let's not do that there. Let's instead write auto POS2 equals ID.begin. Let's do POS_end equals ID.end. POS2 does not equal POS_end. POS2++. Okay. Now, did you kind of see what I did there? This is kind of like the for size t I equals 0, comma, n equals v dot size. Okay, so if you look up here, for auto, POS2 equals ID.begin. So POS2 is now a local variable just to this for loop. Okay, comma, and I'm creating another data type POS_n, another variable POS_end of the same data type, same iterator type, and setting it equal to ID.end, semicolon. Okay, then I'm doing the comparison. POS2 does not equal POS_end, semicolon, plus POS2. Okay? So it's completely analogous to the size t I equals 0, comma, n equals v dot size, semicolon, I less than n, semicolon, plus I. All right? And then I print out for each element, I get that printed out. But, which, I mean, okay. So this is, auto, but not range-based for loop. Which do you prefer? Which is easier to look at and read? Which is more pleasant? Range-based for loop. Okay, that's why it's in there. That's what you should always use by default, if it works. Yeah.
So in the one case when you used auto, you used that instead of the iterator declaration. So that in that case, the auto was taking place of the iterator type, like it automatically knew what to put there. But then in the other case, it seems like when you're using the range-based for loop, the auto automatically takes the value in the iterator and puts it in there. So it's it doesn't seem consistent. And one time it's the iterator, the other one's the iterator value.
The answer is, so the question is, it doesn't seem like it's consistent, auto range-based for loop versus the just regular autoify it. It is 100% consistent. It is exactly the same thing. If you look at the C++ standard, what it tells you is for auto x : ID, it tells you exactly how the compiler takes that statement and how it determines what each of the data types are. And it's literally determined by the return type of .begin and .end. Well, not .begin and .end, but the return type. Yeah, actually, yeah, .begin and .end in this case for range-based for loops. Yeah. So it's at 100% consistent. Yeah.
So just to clarify a little bit, so for auto x : ID,
Mm-hmm.
and you're calling x dot first, which x has already become the data type that the iterator points to, and then the other one is the iterator itself.
Oh, I see what you're. Oh, okay. Okay, yes, I see what you're saying. Okay. What I meant to say was, the first lines, those for loop lines, those are identical. Okay, in terms of data types. But in terms of what x represents versus what the POS represents, yes, The POS is still the iterator type, but the X goes one step beyond the iterator type. It actually is the dereferencing of the iterator type. So let me show you how to make them seem a little more equivalent. Is you replace this line here with star POS2 dot first. Okay? Star POS2 dot second. Okay? Now it's identical, and you think of star X as star POS2. So wherever you see X, you think of it as star POS2. So what it tells you is that the iterator is a useful tool if you need kind of more detailed control over the container and pointing to elements. But the range-based for loop is great if you don't even want that control. You literally just want to say, I don't want to access any iterator types at all. I don't even want to think about iterator types. What I want to think about is every element in my map is a pair. So X is going to just be an object of type pair. And the intermediate step of this iterator is completely ignored, which is really a nice feature to have. But when you're learning how the iterators work, it's a little confusing because the iterators are that intermediate step which connect the container with the values. And so yeah, now it's a little more one-to-one. It's a little more obvious what it's actually doing. Okay? So wherever you see X, it's literally creating the code below and just substituting out POS2 star or star POS2 in place of it. Okay? So in your homework, this is what's really neat. In your homework that's due on Friday, if you define all of those operators that I tell you to define for your homework, you can use range-based for loops on your custom list class. A class that you wrote yourself, you overloaded the right operators for it and the right functions with the right names of begin and end, you can literally apply range-based for loops to your class. This is not a this is not a mystical thing. This is not built into just specific to vectors or lists or whatever. It's just any class that satisfies certain properties can unlock the range-based for loop syntax. And that's what you're doing in your latest homework assignment. So hopefully it becomes a little demystified after this assignment. Whew. Good questions. Are there any more questions? Did I like the Star Wars trailer? No. I did not like the Star Wars trailer. The guy was holding like some butane lighters or something on his light. I didn't quite get that. I did not like the Star Wars trailer. But I think they may have done it on purpose. No, I'm just kidding. I don't know. I am looking forward to Star Wars, though. I am really looking forward to that. I hated the trailer. Okay. Let's keep going. Okay. So thank you for that question, though. That was a very valuable contribution. At least I actually did enjoy it. I love Star Wars. Okay. So, and Star Trek, too, as you can see. And Shakespeare. I used to do Shakespeare back in the day. So I really like, if anyone wants to allude to anything Shakespearean, I will enjoy it. So, okay, here we go. The next type of relationship you might want to consider in practice is not just a map, which is many to one, but you might want to do a multimap, which is this guy Spock can map to multiple elements, not just a single one. Okay? So in a map, it's like a function that is, don't quote me on the exact terms, but remember, a function is just any map where each input has exactly one output. Okay? That's like a map. Each key value has exactly one pair value, or one value one value object. Okay? In a multimap, each key value can map to multiple values. Okay? So it's a one-to-many relationship. So you think of it like the courses that you're taking. Okay? Spock is taking courses in surfing, chemistry, nerve pinching, and logic. You have to learn nerve pinching somewhere. You're not just born knowing that, even if you're Vulcan. Okay? So in that respect, you can't, rather than just like an ID number, which you should only have one ID number, here, if you're mapping to courses you're taking, you are going to have multiple courses. now this is now where having the right coding style becomes more and more important. Okay, you saw the kind of the weird, the really ugliness of just a single map, but now we're going to include multi-map. So things are going to get a lot more complicated. So here's how I would do it. So if I've got a collection of just, Bob is taking Pick 10B and Math 31A, Hamlet's taking Medieval Studies and Revenge 101, it's a multi-map from string to a string, okay? You just keep inserting pairs, okay? And again, the key here is these are distinct items that just share the same key, all right? So you can't have a duplicate Spock surfing twice, but you can have Spock on the left, and you can have whatever else you want on the right. You can put Spock on the left as many times as you want. Okay? So that's the difference with the multi-map. Okay, now this is where things get more fun. Okay, so multi-map iterator also points to pairs. So printing out elements in the multi-map is the same. In fact, let me just show you the difference, why we code this way, okay? So here's my map. If I want to change this to a multi-map, it doesn't like that. Oh, I'm not going to do that. Let me do, so if I change it to a multi-map, a map has this operator defined, but a multi-map does not have that operator defined. But that's no big deal. That was a completely optional way of adding Spock. Let's just add Spock in a more generic way. We'll add Spock using make pair. Spock 3141. Now when I recompile, okay, oops, missing a parentheses. Now when I recompile, everything is exactly the same. Okay? Now when I run, everything gets printed out exactly the same. Okay? This is a beautiful thing. Now, here's why the auto keyword is so fundamental. What would happen if I didn't have the auto keyword? So let's take out the range-based for loop. Let's take out this code here, and let's replace it with what I had from before, which is this. If I had this, which is the code from before, this will not compile because you have to write multi. And did I define POS? And I did it down below too. Okay, so let's make this one 2. Okay. Okay, but I put in the words multi there. Okay, if I just do map, what? Oh, well, that's unexpected. I wonder what that does. Okay, let's try something. Let's insert a bunch of Spocks. Let's see what happens. What? Wait. Let's clean this to make sure it's clean. I guess I've never tried to use a map iterator on a multi-map before. So that's a little different. Okay. Am I sure I did that right? Whoa. Okay. Well, I was going to say it doesn't compile, and that's why you use the auto keyword. But it does compile. But you should never use a map iterator for a multi-map container. It should always match, I think. Yeah, it should be a multi-map. Huh. Okay, well, anyway, use auto. Use auto anyway. Okay, so here's auto. Nothing else changes. Map becomes a multi-map. Auto detects the return type of id.begin and gives you the printout accordingly. Okay? So this is the beauty of auto, range-based for loops, and also iterators. And in 10C, we go over a little more detail the different classifications of iterators and various algorithms that you can unlock for the different data types. Okay. Yeah, so that works the same. All right, now this is where things get more fun. Because if you have a multimap, you might want to print out all of the values in your multimap that have the same key. So you might want to print out all of Spock's courses. So you don't just want to find Spock, you want to find the first pair with Spock in it, and then one after the last pair with Spock in it. That's how the iterators work, right? They work in pairs. So iterator points to the first element, and then the end points one after the last element. And so we have these functions called lower bound and upper bound, and they return iterators to the lower bound is the first element for Spock that has Spock in it, and upper bound is one after the last pair that has Spock as its key. So if we, again, let's copy and paste. So we're searching for Spock. We have found Spock. And now we're going to replace that with ID. I'm not quite sure what mpause is from up here. Okay. And that should all be ID. And then it's a string. Okay, here's the other important thing to keep in mind. So what's the error what is the error that I have right now? Well, don't look at the error, but look at the code that I've copied and pasted in. I've copied and pasted in a multimap of strings to strings iterator. But ID is a string to int type. So yes, the type matters tremendously. If I had just used the auto keyword in the lecture slides, then it would have done what? Done it for me. Okay? But again, only use auto if it's for what type of object? Iterators. Okay? The reason is because I don't want to keep writing this code all the time, and it's really annoying to debug, and because usually you know exactly what type of iterator you want, and it's just a pain to write it out. Okay? So we're going to replace all of these with the auto keyword. And watch as the errors slowly fade away. And they're gone. And it's gone. Okay. And now we got all of Spock's, not really courses, but ID numbers. Okay? So this is basically a preview of what's called generic programming. In other words, programming where you know what the specific data type should be, but if you know what it should be and the compiler can determine it, it will automatically fill it in because it's the detail that you probably don't care to really focus on when you're coding. Okay? So that's that. Okay. So here are some of the common map and multimap functions. Find, max size, size, empty, whether or not the set's empty. Insert, inserts a pair P into the map. Erase, erases the pair P from the map. Clear, count, begin, and let me see if I put it in the next slides. Okay. Do you know how a map stores its elements? I didn't have it in the slide. A map stores a collection of pairs of elements, right? How does it store a collection of objects? Does it store it like an array, like a linked list? What do you think? Binary search tree. Okay? So The reason why you have functions like id.find, the reason why it prints it out in the alphabetical order of the key value is because it is storing a binary search tree. Okay? So you can insert elements in, and you can erase elements just like a binary search tree type, okay? Because that's exactly how it's storing the pairs, storing the elements. Okay? So it's that same idea. Count returns the number of values with key A. Just like with map and multimap, it can be a 0 or 1, or it can have multiple values. For multimap, it also works for multiset as well. For multimap, let's just focus on that. There's the functions lower bound and upper bound. And those return iterators to, again, lower bound is the first pair whose key value matches that key. And then upper bound is one after the last element, the last pair object that matches that key. And then equal range. This is now where it gets even better. Okay, this is now where the auto keyword is really, really important. Equal range returns a pair of iterators. Okay? So you have an iterator, you have the idea of a pair, then you have the idea of a pair of iterators. And what does that look like? Well, check that out. Look at that nonsense. Okay? Multimap, string to string, iterator, mpos. Okay? Now, when we call courses.equalRange, it returns a pair of multimap string string iterators, multimap string string iterators. We can then cycle through all of them by looking at Bob's courses.first, because that returns the lower bound, and is not equal to Bob's courses.second, because that's the upper bound. Okay? So let's replace this horrible looking code with the auto keyword and see how much nicer things become. So let's say we want to just print out all of Spock's courses again. Okay? Now, let's not create another one of these mpauses. We already have an mpause. Now, Bob's courses. Okay, watch this. What can I put here? Auto. And I can just do ID. And I can change Bob to Spock. Ta-da. Okay? So I got rid of all of this gobbledygook of horrible to read, not very stylish looking code, and by using the auto keyword. Okay, now again, technically I told you can only use the auto keyword if it's replacing what data type? Iterators. But what am I replacing here? A pair of iterators. That's fine. That's fine. Okay? I'm trying to replace a horrible expression involving iterators. It's fine. Okay? So again, as long as your auto keyword is hiding the fact that you've got a data type which would look incredibly excruciatingly unreadable because it's either an iterator itself or defined in terms of other iterators, then you can use the auto keyword. But then you'll notice here, auto, Bob's courses equals id.equalRange. See out Bob's courses. But then you just have your iterator mpos, which goes to dot first. While it's not equal to dot second, increment, and you just print out the value. You could even use, maybe not. Well, don't use a range-based for loop here. You can't use range-based for loop here. But you can use iterators to very effortlessly and very readably print out all of the elements within a certain range. Okay, Wednesday we will start discussing templates.